You are trapped on top of a burning building. Death is imminent, and help is nowhere in sight. There is a safe building 6.50 meters away and 3.0 meters lower. You decide to try to make it across. You run horizontally off the building at 8.10 meters a second. Do you make it across? So, 2D kinematics problem. We have our two buildings right here, 6.5 meters apart, x-axis. So this is our x-axis right here, distance x-axis. 3 meters from here to here, and the y-axis direction. So they break down our components for us more or less. Now, our velocity in the x direction is going to be 8.10 meters in the x direction. X2 is 6.5 meters. So basically that's our distance we have to cover. X1 is 0. It's our jumping off point. It's where we start. Our y components, y1, 0, once again, jumping off point. Y2 is negative 3.0 meters. Now, the negative indicates the direction in the x-axis, not necessarily the traditional negative here. Our acceleration in the y direction is going to be negative 9.8 meters a second. Once again, same thing. Direction in the y-axis, not a traditional negative. Velocity is going to be 0. Y1 is going to be 0, jumping off point. So we take our kinematics equation right here. x2 equals x1 plus velocity times delta t plus 1/2 acceleration times delta t squared. So first let's see how long it's going to take us to cover this 6.5 meter distance, because that's what we're going to end up doing. We're going to end up solving for time, because that's one of the components we don't have after we start plugging things in to our equation. So we look first here, because our acceleration for the x-axis is going to be 0. We plug it in, and we realize that it eliminates the whole half of our equation. So we're stuck with 1/2. Our x2, we already know. We know it's 6.5 meters. We have to cover the 6.5 meters. The x1 is 0. It's our jumping off point. And then delta t, once again, that's what we're looking for. We need to know how long it's going to take us at this speed to cover this distance. So we come here. That's what we're left with after we eliminate the other half of the equation. Divide, and we get delta t of 0.80 seconds. So that's how long it's going to take us when we're running at a speed of 8.10 meters a second to make it horizontally this way. So to cover this distance, we got to have 0.80 seconds. Now, how long do we need to make sure that we can cover this distance right here? Once again, we use our normal kinematics equation right here, only we're not x's now, we're y's. So y2, y1 plus velocity times delta t, 1/2 acceleration delta t squared. So y1, 0. Velocity 1, 0. That eliminates that half of the equation. So we have y2. We have the rest of this, except for delta t. So y2, negative 3.0, 1/2 times 9.8, negative 9.8, delta t. We're solving for delta t. So we go ahead and multiply that 1/2 times negative 9.8, negative 9.4. So once again, we come over here, we divide negative 3.0 to divided by negative 4.9. Square root, because remember, delta t squared. At the end of all that, we come up with 0.78 equals delta t. So we need it's going to be 0.78 seconds to make it 3 meters down. At that point, we haven't quite made it across, because we needed this much time to get across, and this is how much time to cover that 3 meters downward. So unfortunately, we don't make it across.